At a super high level, we have an ecosystem of control planes around Envoy. And although there are some open source ones and there's some proprietary projects, the reality is there's still hundreds of organizations that are implementing their own control planes. Many of them in Go on Go control plane, but there's people that have implemented them in other language as well. Um, the idea behind XDS-relay is to try to push a bunch of functionality that people have to build if they're really going to build a reliable and resilient control plane into a middle tier. So you could think of it as like a CDN or a caching layer or a varnish-like thing, but built for XDS. So the first version that we're working on now in open source and we're about to deploy at Lyft is really just a caching tier. So the idea is that it's a lot easier to understand, what the performance profile is, like how many connections it can accept. Like it's easier to load test it. It's easier to put all those resilience functionality like back pressure and circuit breaker and rate limiting and all of that stuff. And that should allow anyone to deploy this thing in front of their homegrown control planes and hopefully increase the resilience of their deployment. Moving forward, there's a lot of other things that we can do with XDS Relay. Like one of the things that I've been talking about is the way, that you really scale out XDS is to move away from what we call state of the world updates to delta updates. So basically incremental, adds, removes, updates of individual resources. But that's very hard to implement for most control planes. So one of the things that we can do in XDS Relay is we can build in code that will convert state of the world responses into delta responses. So this is kind of an example of where people can keep their potentially bespoke opinionated control planes for their organization, but they can deploy this piece of software in front and hopefully handle scale out.